行，我到你的手上，不是你的不的。Okay, good morning. So my name is David Zhang, so marketing director of the Operating Cloud and NFVI from ZTE. So actually, ZTE, everybody know here ZTE? So ZTE is one of the leader in the telecommunication solution area. So ZTE telecommunication solution has been widely used in operators by more than 200 countries and regions. So we are not only have our hardware, but also we have the full set of the open infrastructures. For example, ZTE own OpenStack distributions. So today, I come to here to share ZTE a 5G ready for mix on demand cloud infrastructure solutions for you because 5G is coming. So it brings out a lot of requirements on the cloud infrastructure. How to build a 5G ready cloud infrastructure solutions for 5G services is the challenges. Okay, so today my presentation will divide into two parts. First part is some trend, evolution, drivers, and etc. Second part is technical aspects. How to understanding this for mix, how to understanding this on demand. Okay, so first page, 5G is coming. So today I'm here, I'm not wanted talking about what is 5G or why we need 5G. I want to emphasize that is 5G is coming. The 5G new services, for example, the URLC or enhanced mobile broadband, it figure out the new requirement to the infrastructures like the low latency, high bandwidth, high speed, and etc. Something from the machine talking, machine communications. Okay, this kind of requirement bring an impact, require changes on the cloud infrastructures. I think nowadays, okay, most of your cloud infrastructures is centralized, right? You deploy everything in a centralized database or two centralized databases with active standby or geo redundancies. Your cloud EPC, your cloud IMS, your cloud OSS, BSS, or your IT systems, centralized. But due to the different requirements on the latency, on the bandwidth, on the speed, the centralized deployment is no longer fulfill all the service scenarios. We are looking for a multi-layer distributed cloud infrastructure architectures. So today I'm emphasizing a distributed cloud infrastructures. But what is the key technologies or key characteristics for this kind of distributed cloud infrastructure? How to understand this? Okay, let's see these pictures. Okay, I will assume that is the network, the cloud infrastructures will be a hierarchical architectures divided into maximum 3 layers. First, we will have the core cloud. Okay, you deploy a centralized element, latency insensitive element in this core cloud. For example, your PCF, SMF in 5G, and the gateway control plane in the core site. And also we have edge data center and access data center. So you can deploy different kinds of applications in different level of data centers. For example, let's talk about access data center. Access data center, we will assume is most close to the subscribers, provide the best, the lowest latency, best bandwidth. What kind of elements? For example, your Cloud RAN. Your Cloud RAN control plane, multi-edge access control services, and UPF, the packet plane in 5G services. This kind of services has extreme requirement on the latency bandwidth. We should deploy them mostly close to the subscribers. And something we deploy in between. So I'm talking about 3-level data centers, but it is not a strict regulations. Maybe if you say, okay, your country is not big enough, maybe you only have core cloud and access cloud. Or even your country is really small enough, maybe you only have one. But I'm talking about in China. So China is quite big. They may have 3-level data centers. So totally it's a hierarchical data center architectures, right? And also for each data center in core site, you have generic hardware. It is x68 platform, or ARM platform, and etc. And you have centralized management system. You have multiple resource pool management, cross-vendor, cross-private cloud, public cloud. And also you have the AI-based O&M tools, right? And also in edge, you not only have the generic hardware, maybe you also have some accelerator. For example, the GPU, FPGA, SmartNIC, in this way to provide a better performance. And also in the edge data center, you are also not only common hardware, the accelerator, but also you have different kinds of hardware. For example, some integrated hardware, all-in-one node, multi-node hardware, different kinds of hardware to fit in the limitation of edge access data centers. Also, for the OpenStack point of view, okay, in the access side or edge side, you are not looking for a full set of OpenStack installations. You expect maybe some light-weighted OpenStack installation to save resource, save CPU core, save memory, save your disk space, right? So do everything, deploy everything as demand, right? So this is the full picture of ZT understanding on a distributed cloud infrastructures. So later on in the next few slides, I will put a little detail and emphasize the most important key technical aspects. Okay, let's have an overview. What is ZT we call the full mix on-demand distributed cloud infrastructure looks like? How to understand it full mix? First is mixed operation maintenance approach, automation and intelligence on demand. You may have different, in the whole life cycle of the network. You will have software installation, software upgrading, do daily operation maintenance, okay, optimization, right, end-to-end. We have end-to-end operation maintenance tools to make your network management to be automation and intelligence. And also this is AI engine based, right? So you can choose an O&M approach as you demand, okay? Second is deployment on scale, on demand, okay? You can install a full set of cloud platform here, but also you can install a lightweight OpenStack here, or even computer storage OpenStack merged in one node. So this flexible deployment mode on demand depends on what kind of location, what kind of data center, what kind of service you would like to deploy, right? And also mixed acceleration scenarios. We will say, okay, the acceleration, the CPU is not enough now. We are looking for the GPU, FPGA, and OpenStack community. There is some projects is ongoing to focus on this kind of acceleration scenarios, right? So ZT, we are make a lot of contribution and efforts on the hardware acceleration, how to manage different kind of the accelerator, how to make compatible with different accelerator, and how to open this capability to the up-layer applications. Okay, we have manage different capability of accelerations you can use on demand. And also a mixed cloud resource pools. You may not only have virtual machine bare metal, but also you have the containers, Kubernetes, right? You not only have ZT resource pools, but also you may have other vendors, Red Hat, other vendors, OpenStack, or even resource pool from VMware. And nowadays, some operators are talking about, do we really need or necessary to deploy the virtualized EPC, virtualized IMS on top of the public cloud, right? And also, I think this would be one technical trend. It's possible from a technical point of view. And nowadays, in this way, you need to manage the public cloud resources like Amazon, like Ali Cloud. So we should, from a cloud management point of view, you should have such capabilities. So it is a private cloud, public cloud, heterogeneous management. So you can choose a cloud resource type on demand, whatever container, whatever bare metal, whatever ZT, whatever third party, whatever Amazon, whatever private cloud, whatever public cloud, right? So this is full mix understanding. So first mix, just now I mentioned, you can not only manage ZT cloud here, ZT cloud include ZT virtual machine, bare metal, and container, okay, but also you can manage the VMware, third-party OpenStack, or even public cloud, Amazon resource. One cloud management up to manage all type of the cloud resources. So this is a very powerful cloud management engines. This is totally complete designed by ZT. And also, second, you are looking for maybe, okay, now you heard a lot of things. For example, the Kubernetes over OpenStack, OpenStack over Kubernetes. Okay, you have virtual machine, you have bare metal, you have containers. we are also looking for solutions to deploy Kubernetes over OpenStack. We can use a unified OpenStack management framework to manage the virtual machine, to manage the container, to manage the bare metals. So because OpenStack has more than a lot of years, right? So Kubernetes maybe is young, still young. So we can use some OpenStack mature modules introduced into the Kubernetes. Then we can have a better maturity, better Kubernetes built on OpenStack to build on services. So this is what we call dual core drive. Kubernetes, OpenStack, dual core drive the service innovations. Okay, how do you understand this deployment on demand? Okay, this is also easy to understand. First, you may have a centralized OpenStack deployed in your centralized data centers. Okay, but for your edge data centers or the access data centers, you're looking for maybe lightweight OpenStack. Or you adopt some OpenStack Cell V2 deployment. You deploy a local message queue or Nova Cell node in each data center, or even you use the available Zoom mode. Everything managed by your centralized data centers. So different kinds of approach, different kinds of alternatives enable you to have a flexible deployment on the OpenStack itself. To save your energy, complete set, or a lightweight set, or even nothing here to manage by the centralized one. It's very flexible to fulfill your diversified requirements, right? And also for the containers, just now I mentioned the dual cores. You can deploy containers in virtual machine. You can deploy containers on the bare metals. All the bare metal and the virtual machine resources will be unified and managed by the OpenStack. So OpenStack will be the unified resource management for the virtual machine for the bare metal. So you can also build the container on the bare metal and in the virtual machine. So this will dual core drive. But of course, you can choose if I don't need OpenStack, because OpenStack occupies resources, right? You can deploy everything directly on the bare metal. It's also possible here, right? You can deploy everything directly on the Kubernetes. There's no OpenStack at the bottom, right? So acceleration, right? So nowadays we have different scenarios to enable you to have accelerations. For example, some 5G RAN, NFV accelerations, the 5G core network accelerations, or even NFV accelerations. A lot of scenarios. So CPU is not enough. Now we must introduce GPU, FPGA, or MP, and etc. The third-party accelerator into your network. The OpenStack, ZT-Tax, should manage this kind of accelerators, this kind of third-party hardware. And ZT, we have the cooperation with my colleague Intel. So we adopt their FPGA and with this kind of hardware to provide this kind of acceleration capability to the up-layer services. For example, we are talking about SBC. Do you know SBC session board controller? This is one element in the IMS. ZT make a test, a trial. That is, nowadays we use Intel CPU to do the transcoding, but we found it's not cost performance solutions. But we do use GPU. We found, okay, if we talk about transcoding, the efficiency of one GPU is equal to around 107 CPU cores. So use GPU to do the transcoding is a cost-effective, cost-performance solutions in the NFV solutions. So the OpenStack should manage the GPU and open this GPU capability to the up-layer services. The SBC is one kind of services. Or we're talking about another kind of acceleration. We call it OVS, offload acceleration, for the gateway or the UPF. We use FPGA-based SmartNICs to do the accelerations. We are no longer fully dependent on the CPU-based OVS packet forwardings. We found, okay, if one FPGA, the efficiency of one FPGA-based SmartNIC plus 2 core is almost equal to the performance provided by the 12 Intel cores. It is up to the 30 gigabit. So it is also a cost-effective solution if we adopt SmartNIC on FPGAs. Okay, next my colleague, my friend, Intel, Mr. Ding, will share the Intel product portfolio here.
Yeah. Thank you, Mr. Deng. Mr. John just mentioned in ZTE's 5G infrastructure, there's a lot of utilization of Intel's accelerator devices. For this part, I will talk about most of the Intel accelerator devices products. We are across all the computing, network, and storage areas. For the computing, we can see recently we have released the latest generation of the Intel Xeon platform for high-performance computing. And also we have some GPU devices integrated with the Xeon platform also. This is and also in the computing area, we have some FPGA devices. As we know here, this is two generation of the FPGA devices. It's Altera A10 and S10. The two generation products, very FPGA devices can help a lot in the 5G infrastructure setup, we know. In the networking part, we have the product of SmartNIC like this. SmartNIC here is that's the integrated FPGA chip inside the NIC devices. And the FPGA devices can do a lot of networking package processing offloading prefetcher to increase the performance of the networking bandwidth a lot. And the storage. In the storage area, we have several different type of devices. This one is the standard NVMe interfaced SSD card. The product name, we call it the NVMe interfaced SSD devices. And this one is very important. We call it OpenDC persistent memory. It's the interface, the hardware interface, the DIM interface in the platform board, the same as the memory chip. So it can provide a very high bandwidth for the storage also. And the performance is also okay. And also the capacity will be very large to several, for example, the 2T for the whole platform for the persistent memory. Okay, that's all for the introduction. Thank you very much.
So thanks, Ms. Ding. So let's come to the last 2 minutes. Okay. So we come to the last mix, the mixed O&M, automation and intelligence on demand. Actually, ZT can also provide end-to-end operation maintenance tools across the whole life cycle of a project. For example, when you're trying to do the installation upgrade, when you're trying to do the operation inspection, we're trying to do some intelligent watching, fault management, log analysis. For each approach, each step, we have a dedicated tools to enable you to have network automation and intelligence. And also, okay, all these tools behind it is AI engine driven. So we collect different performance data, logs, alarms from ZT equipment, from ZT environment, from third-party environment, computer storage node, and onto a centralized AI-driven engine there. We have offline training, knowledge base, online analysis, big data database, and machine learning to learn, okay, what is situation of the healthy, detection exceptions, root cause analysis, capacity forecast and optimization, automatic closed loop scaling out, and self-healing based on the alarm. So it's totally end-to-end closed loop. This kind of AI-driven operation maintenance engine can enable you to release your efforts, right? To have a full network automation and intelligence. So this is all what I want to introduce today. So it is full mix on-demand distributed cloud infrastructure from ZT. So many thanks, everybody here. So thank you.